How's it going, everybody? I wanted to give everybody a quick update as to where I'm at with my studies and things like that. Got the written exam in a couple of days for CCIE, and hopefully everything goes well and I end up passing that on my first attempt. Um, uh, Nerves are a little bit there, but I think that comes naturally with any type of high-level exam or any exam, really. What I wanted to do additionally was kind of run you guys through a topology that I built that kind of mocks what I've seen from a couple of vendors for the full CCIE lab. This is my interpretation of what we could possibly see for the lab side of the exam. So for those of you that aren't familiar with what CCIE is, I'll give you kind of a quick 30-second recap of what actually CCIE is. It stands for Cisco Certified Internet Expert. It's Cisco's top technical certification. There's two parts to it. There is a written qualification. It's usually between 90 and 110 questions. They give you 2 hours to answer them. And pending a pass on that, if you pass, then you are then able to, you're then qualified, I should say, to go take the CCIE lab exam, which is what the Advanced Technologies class or the CCIE RNS V5 video series is for. So if you are interested in knowing more about CCIE, go check out cisco.com/go/CCIE, and kind of gives you a brief overview as to what the exam is and what you can do to pass and things like that. There's several vendors out there that do offer training and things like that. I happen to use INE or InternetWorkExpert.com for my study material and preparation, things like that. They have videos and workbooks and full-scale labs, things of that nature. So that's a high-level overview of what CCIE is. Now the topology that you have in front of you, and a topology simply means diagram. So if you're not familiar with what's the term topology, then it kind of comes from the term topography. If you ever take a look at the ground, get your head real close to the ground and you take a look, you see all the bumps and the hills and the valleys, peaks and the valleys on the ground. Topology is the network or the IT version of that. So you're able to see what's where, how it's connected, things of that nature. So that's exactly what this is. This is what that is. So what I wanted to do is kind of give you an overview as to what you're looking at, so that if you see this topology, you're going to know what you're looking at, things of that nature, stuff like that. So you won't be completely like, when you see it. But basically what this is, I wanted to take a high-level view of what an enterprise network looks like today. So if you're not familiar with an enterprise, is going to be a very, very large company. So in respects to that, there are hundreds, if not thousands, of large enterprise companies in the U.S. and all over the world. And it just so happens to be that I took the network diagram that I've seen from other people that I studied CCIE with, and I took this one and I kind of built it from that. So this is kind of a hybrid topology. Covering a multitude of sites and operations and things like that. But what you see here in front of you is realistically the what we're going to end up walking through once we get through the technology labs. So that's going to be me walking you through all of the technologies. This is going to be a full implementation. So what we're going to end up doing with this diagram is, you see up here we have the corporate site. We have 3 routers. And then we have what would be considered to be a stub router, and we have a couple of options over here with connectivity out to the service provider. So all of this right here, this is all service provider. So what I actually decided to do is I wanted to make it look more like what you probably would see in the real world. So when you're dealing with the service provider in your normal network, a lot of what you're going to see is going to be a connection off to the internet, and in most cases a connection off to your private WAN connectivity. All a WAN means, or a wide area network, simply means that you're going to have connectivity just to your corporate corporate offices. And corporate offices not meaning that it's a corporate site, but it's an office that connects to the corporate network. So all of these connections right here that you see, all these guys right here are going to be the MPLS circuits. So we'll go through a full MPLS deployment So all these are the MPLS circuits. And as you can see, there's plenty of them. I have 6 going out, so we'll have multiple routes added in, multiple routes being taken out, things of that nature. So that'll be all stuff that you guys will definitely be able to see as we're going through. All of these type of circuits right here are going to be the serial connection. So this is going to be your BGP connectivity. So BGP being the Internet Routing Protocol, which we have ISPA BGP, ISPA BGP, and Internet. So basically what I'm doing here is BGP is the Internet Routing Protocol. So basically what I've done is I've taken the connectivity between these 2 sites and we're dual homed. So we're able to have 2 routers connecting to 2 different routers on the provider side. So basically what that allows you to do is it gives you high availability. So if this circuit goes down, you can forward out this circuit or this circuit. And it gives you the ability to use different local, the BGP path selection process, so you can modify the weight, you can modify the local preference, you can modify the AAS path number. There's a multitude of different things you can do, and that's one of the great things about the network of today that you couldn't do, 15, 20 years ago before these technologies were out there. So that's going to be what we're going to have to run through. This is going to be dedicated just BGP routes. So then we also have these connections right here. And these connections here are going to be the ones that are going to be providing basic cable internet. So let's say, for instance, that you have your corporate site and you have your regional office. So these sites are the ones where you have, say, for instance, back here we have a remote DC. So let's say you've got some sort of data center behind the scenes where a bunch of web servers and a DMZ are sitting. Well, a DMZ is an area where external traffic can reach an internal device, but the external traffic is not able to see an internal traffic on the trust interface. So in most cases, a router is going to have 3 different interfaces. So draw a router. You're going to have, this is going to be the trust interface. This interface is going to be what the local LAN is going to be on. Then you're also going to have, and I'll draw a lightning bolt, this is going to be the untrust. Now the untrust is going to be your internet side. So where you have internet traffic coming in, the public IP address, and then we have over here, we're going to have the DMZ. Now the DMZ, traffic is going to be able to come through here and going to go back out, but traffic from here won't be able to go through. And the reason why that is the way it is because of the fact of the way NAT works and the way that zone-based firewalls work. If traffic is not solicited from inside to outside, so if the traffic is not requested from an internal resource, then if traffic tries to come in this way, it will be blocked. It'll die. So that's going to be one of the things we're going to talk about a lot when we come into our discussions about like BGP, DMZ bandwidth, things of that nature. So these are all going to be things that we run through as we're progressing through our topology and our our live lab walkthrough. So that's how that is going to work. Now you might sit there and go, well, how come? Well, you're not going to be able to do like totally stubby areas and EIGRP or DMVPN. Au contraire, this right here could be considered to be an OSPF not so stubby area or a totally not so stubby area because of the fact that we have an area back here that could be external. This guy right here could be GoDaddy.com. This guy right here could be a firewall at that site. Or this could be a remote location. Maybe you've got an extranet. Maybe you have a partner connection to say, let's say for instance, this is your data center router, and then you have a connection off to say Amazon AWS, and then you have you have connections back here. Well, you are routing all of this. So this could be a totally stubby area where you're allowing routes external to your corporate network to be redistributed in to be accessed by, say, somebody down here at Regional Office 2. So we'll take a look at that in detail when we get to how all that stuff works. That's one of the big things is understanding what options you have in the network. Now, and you might be thinking, okay, well, how would you do DMVPN? Very simply, we have the corporate site here. Let's say, for instance, R1 is going to be our hub router. Well, what we could do is we could configure NHRP. NHRP is what is used. NHRP is the routing protocol that is used to enable DMVPN, which DMVPN is known as Dynamic Multipoint VPN, where it's a routing protocol feature which allows you to take external or internal requests and send them over a private cloud type of connectivity. So it does not require any type of service provider intervention, meaning it doesn't matter what transport it uses. So you can use cable, DSL, frame relay, ATM, it doesn't matter. So we'll talk about this in a lot of detail with some of the things you have, because every one of these, so 27, 22, 18, 5, and 4, all of these routers could be spokes to your DMVPN network. So you could very easily have DMVPN GRE tunnels going to each one of these sites, and what that would give you the ability to do is route traffic to those. And one of the other benefits to this, which is one of the things I like a lot about it, is you can do multiple clouds inside of DMVPN. So let's say, for instance, R4 is your regional office, and back here we have our, oh, ran out the screen on that one, we have our remote DC site. Okay, so what you could basically do is you could set up DMVPN to where you could actually have a VPN to these two, and then you could take your GRE tunnels and set them up to all these guys, and have this as a trying to draw a line here. You could have this guy set up as a hub for traffic coming from here. You could also have this guy as a hub connecting to all these guys. So you could have dual hub. And the benefit to that is it gives you a lot of scalability when it comes to how far do you want to take your network. Now, this is actually outside of the scope of CCIE, because you're not going to have to go through and do dual hub. You're going to do a single hub to, I'm guessing, 3 to 5 hub spokes with a pre-shared key going out and then being sent back in. Now, depending on what you do, you might have to use virtual tunnel interfaces, or you might have to do GRE over IPsec. It just depends on what it is that the CCIE lab exam has you do. So that's going to be one of the things we're also going to take a look at. So that's why I like the scale that we're at with CCIE, because you never know what they're going to throw at you. Now, beyond that, we're going to get into a lot of MPLS. MPLS is pretty much going to be just the L3 VPN, which, if you don't know, if you're not familiar with MPLS, it's a service provider technology that allows you to take customer traffic. So if you're familiar with the legacy frame relay or ATM, this is an enhancement. So MPLS, as you see right here, actually stands for multi-protocol label switching. And what that basically means is you're able to encapsulate multiple protocols. So it can be IP or non-IP, and it label switches them. Meaning you're not having to layer 3 route, you are layer 2 switching. Now, technically speaking, MPLS is actually a layer 2.5 encapsulation, because it takes the MAC address, you get your layer 2 header, then actually the MPLS header sits right here, and then you have your layer 3 header that sits up behind here. So MPLS sits right in between those two. So basically, as we're going through this, we'll talk about the different things that you're going to have to worry about with MPLS, like multi-protocol BGP for VPN v4 routes. We're also going to talk about the LDP, or a label distribution protocol. We're going to talk about L3 versus L2 VPN. And that's going to be a lot of the stuff that's going to be persistent in the route, or the written exam. It's one of these guys, but we're also going to talk about the actual lab exam. So I will take it as far as the operating system will allow me to do so, and then that'll be pretty much where we kind of cut the limit, because we don't want to go too far outside of the scope of the exam. We want to keep pretty close to it, but be able to adapt to a question that's on the exam that you may or may not have studied for. So that's kind of the premise behind all of what I'm doing here. That's going to be MPLS for the most part. Now, you do see a couple of different providers. So one of the things I'm going to study before I actually deploy it is a concept called carrier supporting carrier. And if you're not familiar with this term, or CSC, what this basically means is this is a way for you to do inter AS VPN. And basically what this means is, if, let's say, for instance, you have this guy right here is AT&T, and this guy right here, this guy is TW Cable. But let's say you have AT&T as a tier 1 provider, meaning he has end-to-end high-speed fiber optic connectivity from LA to New York. Let's say that Time Warner Cable does not have that. Let's say Time Warner Cable is a tier 2 provider. Let's say that they're in the different regions. So I live in the Wisconsin area, And let's say, for instance, you're from Chicago, so you live an hour and a half south of where I do. Well, that's great, but if you're familiar with Time Warner Cable, you're also probably going to be familiar with Comcast. Comcast is the Illinois version of TW Cable, and I believe Comcast bought TW Cable out completely, but I don't stay up to speed on how all that stuff works. So basically, what that means is Time Warner Cable will probably hand off traffic to AT&T. That is where a carrier or AT&T would support Time Warner Cable traffic. So essentially what would end up happening is, let's say, for instance, you have, let's see how far I can go back with the Control Z thing here. Okay, cool, all the way. Well, let's say, for instance, you have VPN connectivity. You need to spin up and you kick off another line from Time Warner Cable to your customer edge router. What ends up happening here is you peer with this guy with BGP, which is the most common routing protocol you're going to see with MPLS, because there's really no route redistribution needed on the provider side because it pretty much does it automatically. So what ends up happening here is you are going to use Time Warner Cable as your ISP for MPLS. Well, what's going to end up happening is I heard a ding in the background. Oh, I bet you my... Anyway, nothing for you guys to worry about. What more than likely is going to happen is Time Warner Cable is actually going to pass this traffic off if it can't get that traffic to wherever it's got to go inside of the Time Warner network. So he's probably going to do what they call a carrier supporting carrier or a provider handoff. So he's going to hand that off to AT&T, and then AT&T is going to take that traffic down to close to wherever it is he's got to go. Maybe he hands off to, say, Cox Cable, or Frontier, or another last mile carrier. What I mean by last mile is typically the last stretch before it hits the customer network. So, for instance, this might be cable, or it could be DSL, or whatever the case might be. Just depends on what the last mile media is. So we're going to talk about that as well, because I think that's going to be an important thing to understand when we get through how all this stuff works. If you don't understand what the provider is doing in the background, it's going to be difficult for you to try to negotiate with them on different aspects of that. And then we're going to talk about security. Now, security is going to be a big deal in most networks. Now, security could be a couple different things. It could be a VPN, or virtual private networks, where you're actually doing secure connectivity to your network. So that could be secure transport to the router, where the router acts as a VPN. That's supposed to be a V. VPN, termination device. So let's say it's doing remote access and LAN to LAN or site to site VPNs. So it could be doing that, or it could be doing some sort of like control plane policing, or control. That's supposed to be a control plane protection. So it's actually trying to limit the amount of telnet sessions, or trying to limit pings to the router, or something like that. We will talk about AAA. AAA is authentication, authorization, and accounting. We'll talk about that and how that would work, and how you can set up different method lists and things like that to allow different groups in, where you can actually point. I use TACACS in my network, so when I log into a router, I actually use a router or a switch. I actually use TACACS, and we actually set it up so that when I log in, I use my username and password on a device. It actually checks with the TACACS box back at my corporate site or with a VPN, and then it says, okay, what can I do? Well, I have unlimited access because I am the chief engineer for my network. So then I'm able to go in and say, okay, I want to do, I want to go to global config, and I want to, add a route, so plus a route, and that'll allow me to do that. So AAA can allow you can get specific as to what the user can do. So we'll talk about that as well. There's a lot of other ones that are out there, different things we can work with. And then one of the big ones, or two of the big ones that I think people have the most difficulty with is, I think I might have overstepped my bounds with, let me just do this real quick. Voila. A couple of things that I see a lot of people struggle with is quality of service and multicast. Multicast itself is actually pretty straightforward once you understand what it's trying to accomplish. So multicast, I'll talk about QoS here in a second. Multicast is basically taking a multicast feed. So let's say, for instance, this guy right here is a IPTV server. And basically what ends up happening here is he is sending a feed out to R4. And let's say R4 is the rendezvous point. Well, R4 is going to be the rendezvous point for the rest of the network. Well, what you could do is you could say there's a user on R11, he signals to R11 with IGMP and says, hey, I would like to join this multicast stream. What ends up happening is R11 is running PIM version 2, which is the default. Maybe he's running, let's say, sparse mode. So, well, we would need sparse mode to run an RP, right? So what ends up happening is that IGMP message would get replicated out to R18, which then would kick it up to R4, and then he would receive a join message, and then all of a sudden there would be a multicast feed sent to just this guy. And that's how multicast would work. And that's a very, very high level view of how multicast would work. But that's the idea behind it. We'll talk about more of that in detail coming up later on. Now, quality of service is typically used to control how the network will respond to different applications. So, for instance, voice over IP, everybody's favorite thing to talk about when it comes to QoS. Well, that's just a very small piece of the pie. I like to think VoIP is about 10% of the network. Well, what happens with the other 90% of the network? Well, let's say my company happens to use a lot of VDI. And not VDI in the respects that you have to have an iPad, you dial into a Citrix server, and you're able to get a Windows desktop. You can do that. That's one option there is. But we use a lot of VDI. We would prefer to put a network or take a person's computer that maybe they have an application that they need that is going to be accessed by several people. Well, basically what ends up happening is we can take that application, we can put it into a virtual environment, and then we can put that, give that IP address or the name of that device, and allow users to RDP or remote desktop into it. So that's going to be one of the things that you can actually prioritize different applications. You can use NBAR, which is network-based application recognition. What NBAR does is it allows you to look at the layer 7 protocol. It says, okay, well, if it's going to be ICA for Citrix, I want to give that priority over, say, web traffic or whatever the case might be. That's going to give you a lot of scalability in your network. I use NBAR for pretty much probably 60% of my classification. That's actually what NBAR does, is it classifies traffic. It takes that traffic, it looks at it, it says, okay, well, this is web traffic. Well, then it looks at the policy map and it says, what do I do with that traffic once I've classified it? From there, we drop down to the policy map, and the policy map says, well, we're going to give it 20% of the bandwidth, and it's going to be forwarded out to this interface. That's what the policy map does, is it says, well, what do you do with it, and where do you send it? Then the service policy gets sent out, and maybe it goes this direction. You can also do this with policy routing. So if you want a policy route voice over IP traffic over a faster link that's maybe got less delay or whatever the case might be, that's also going to be an option. So that's one of the big deals that I like about NBAR, because it gives you a lot of flexibility. You don't have to sit there and try to create an access list, to try to match a protocol, to try to match a port number, or anything like that. You can do those, and you can get specific with your port mappings. Let's say, for instance, a specific protocol. And in my environment, I work for a communications company, so a lot of times I'll get a request from a TV or radio station that we happen to support, and that TV or radio station might say, well, I have this backpack device that's going to send a feed over the internet back to the firewall, and from the firewall it's going to give a feed to another device which is going to allow that stream to go over the internet. And I'm like, great, that's TV stuff. I don't deal with TV stuff. My job is to get traffic to the router, and then from the router, how do I get it to where it's got to go in the DMZ? Because remember, everything that I do in a network, if it's external to internal, it's going to the DMZ, unless there's something else for like a NAT or something like that. But usually we don't do TV stuff via NAT. Well, we do, but I don't want to get too complicated. I'm trying not to get too technical here. But the idea behind that is if you want to take traffic in and you want to give it priority, there's multiple ways of doing that, and I lost my train of thought. I love how I try to pull myself back sometimes because I don't want to get too deep. But the moral of the story is it gives you a lot of flexibility. So, for instance, if you're continue control TB over the internet. So if TB comes in and I want to say, okay, what is it? Where does it go from here? So it might go to a, it might go across a VPN to another remote site. Well, that'll be something else I have to take into consideration. So depending on what the point of the implementation is, that's where I had to talk to the radio and TB engineers and say, okay, what's this for? And then from there, I'm able to determine what I need to do and how I need to do it. But these are two very, very large. They're not big topics on the exam, but they're going to be topics that we're going to have to spend some time on, because when you're going through CCNA or CCNP, they're the least talked about. I didn't actually get into QoS or multicast until I started studying for my CCIE written exam, and that was about 8 months ago. And I was like, I've heard of it, we use it, but I didn't know a lot about it. You know what I mean? And so you're Googling things, you're trying to figure stuff out. And that's when I realized the difference between policing and shaping. I started learning about congestion management, which is policing or shaping. There's congestion avoidance, which is going to be trying to avoid congestion, which is a technique uses RED or random early detection or weighted random early detection. And the big one you're going to see a lot of is going to be class-based weighted fair queuing. And we'll talk about that, where you can prioritize traffic based on a class. So you can classify traffic different ways, different policies, things like that. We'll talk about that in detail, understanding how the hierarchy with using the modular quality of service command line interface, the MQC, and the hierarchical queuing framework. These are going to be things we're going to talk about a lot, and I feel like the services side of the house is going to take just as much time as the infrastructure side of the house. And you might say, well, what's the difference? Well, infrastructure, which is going to be your layer 2, layer 3 routing, or layer 2 switching, layer 3 routing, that's going to be getting the network up and running. How do I get traffic from here to traverse all the way through here over to R11? Well, there's a lot of ways you can do that. That's great. Now that I've enabled end-to-end connectivity, which is actually the point of the CCIE exam, how do I take that the next step? How do I prioritize traffic to go this way if it's going to be, say, web, and if I want to send an FTP stream over here to R19 where there might be an FTP server attached to it, how do I prioritize that traffic to go this way? Well, you could use policy routing, or you could use some sort of queuing, or you could use, say, for instance, you could VPN it. I mean, there's a lot of different techniques that you can use to get traffic from where it's got to go, but it's understanding what those techniques are in order to enable you to do what you need to do. And that's one of the things that's the most time-consuming, is when you're in the lab exam. And I've talked to a lot of CCIEs. I work with I don't work with any directly, but I know a lot of them from the internet and going through my studies, and all of them keep telling me the same thing over and over and over again, and that is best possible solution for whatever you're trying to accomplish. Now, that best possible solution doesn't need to be some extremely complicated, convoluted, in-depth solution. That's not what the CCIE is looking for. The CCIE is looking for something that's going to be straightforward and easy to implement. Now, that doesn't necessarily mean that that's going to be the ability for you in the exam, because they might have a restriction where it says, well, you need to send web traffic this way, but from 10 a.m. to 2 p.m. And that could be that might be your only specifics in there. That could be your restriction. Well, that means I'm going to have to use a time-based ACL. Okay, so time-based ACL. Then I'm going to probably, and it says don't use policy routing. And you're like, oh boy, well, that would be my first instinct, use policy routing, because then I can call that to an extended access list via time-based ACL, and then I can route traffic to whatever I want to for this specific amount of time. So, off the top of my head, I wouldn't know how to do that. I'd have to go look that up. But see, that's where we're going to work our way to. That's where you have to understand is there's going to be multiple aspects of how you actually end up doing what you need to do. So don't look at the CCIE as this massive amount of information I'll never get through. I'm taking it one topic at a time. So like right now, I'm running through OSPF. And OSPF is an extremely complicated protocol. Now, it's not just router OSPF1 and then a network statement and whop, bam, boom, you're done. The reason why it's so complicated is because of its hierarchical nature. You've got different areas, you've got different area types. There's an OSPF state machine where intra-area route is preferred over an intra or inter-area route. So these are going to be things you have to take into effect. If you're trying to send traffic to this one, but it's routing this way because it's an intra-area route, there's a reason for that. So that's going to be one of the things you have to understand when you're going through your studies, is to know why something does what it does. That's kind of the purpose of becoming an expert, and that's one of the things that I see a lot of people, they understand that's what they were trying to get to, but they sometimes drop the ball with what they really need to know. They want to either get through the section and just be done with it. They don't put the full effort into understanding what it is. And that's why CCIE is not a destination, it's a journey. And the reason I say that and write it out at the same time is because it's just like any other thing that you're passionate about. I know a lot of mechanics that are really, really good. Well, just because you can change a spark plug doesn't mean you're an auto service expert. An auto service expert to me is somebody that's you can come to them and say, hey, the car's doing this. It's making this real rattling noise when I get about 65 miles an hour, and based on the model of the car, the age, and something else behind the scenes that the customer, may not know. The ASE guy might say, well, it could be the fact that you've got a loose tie rod, and you hear this rattling noise. I'm not a mechanic. I'm just kind of going out there on a limb with a possibility here, but it's not the destination. Once you get there and you have your number, congratulations. Awesome job, way to go. What do you do from there? Well, getting there is going to be half the battle. The first part of the battle is understanding what you need to do. And realistically, you're never actually ever there. You may earn the number, but you're still going to have to keep up with technology because the stuff's always changing. I mean, this is the way it goes. So in a recap of what we've discussed so far, which I think I've covered in pretty much a lot of detail what we're going to be going over and a lot of what you guys are going to be seeing here. Let's see how far back I can go. And you know what? I didn't save my copy, so I won't be able to open up a new one. Yeah, I figured that's about as far back as I'd be able to go. That's okay. I've got it pulled up on my other screen, so I'll be able to get another copy up here. So that's what we're going to be working on. This is our topology, and we'll go from there. Now, if you're familiar with the term carrier supporting carrier, I may not be able to pull that off with this topology. So we're going to work through this from start to finish. This is going to be a long drawn out series for this particular part. So right now I'm doing the Advanced Technologies class, and I'm going through it as I'm training or studying for CCIE. So as I'm finishing up a particular section, so I just finished up RIP and EIGRP. So once I get done with the lab or the fundamentals of OSP, I'm going through all the workbook sections and stuff like that. Then I'll go back through and I will record and deploy the OSPF section. I just said deploy. Ha ha! Crack myself up. I will release after I produce all of the OSPF videos, and then from there, what I'll end up doing is I'll move into like DMVPN, and then I'll move into redistribution and things like that. I'm kind of following INE's pace. So if you've ever been to INE.com, go check them out. They're great. That's my company right there. I don't own it. I just use them. That's where I go. That's my saving grace. If they weren't around, I wouldn't be where I'm at right now. So we have that, and then once all of that is done, so once we get through MPLS, BGP, IPsec, VPNs, security, or infrastructure services, infrastructure security, things like that, and system management, and we're done with the Advanced Technologies class, then we will get to the lab walkthrough, which is actually what all of this is. It's a lab walkthrough. So we're going to take this from nothing to a full-blown implementation. So we're going to basically start with an 8-hour exam. We're just going to take a lot more than 8 hours, by the way, to do this. And we're going to walk through step by step how each thing should be done based on, we'll take a bunch of different scenarios, we'll lab them up. I think we'll be okay with this topology. I haven't tested anything out on it yet, but I took this from a friend of mine, and I made a hybrid copy of it. This is just kind of my master plan, if you will. So one of the things down here that I wanted to point out too, while you're paying attention to me, Babel, is when we're dealing with different things. There's a thing called MPLS TE or MPLS FRR, which is traffic engineering and fast reroute. which you can actually, or a link and node protection, which basically means it calculates a backup path. So if this link goes down, it can quickly reroute traffic this way, things like that. So those are going to be other options we're going to bring in. And another sidebar note. Currently, all of this stuff, this topology is in GNS3, which I don't think I have on my other monitor at the moment. Yeah, it's over here. Actually, you know what? Let me bring it over so you guys can see this. And let me minimize it here. So I'm going to bring this guy over. This guy right here is my actual lab topology. Oh, you guys can't see it. That's right. So let me go full screen with this guy, and then oh, what? Oh, well, that stinks. You know what? I bet you my server crashed. Yep, my server crashed. So that's okay. I'm actually getting a new one because I've been dealing with that a lot lately. Server crashes. So I've got a Dell cloud server router or server router. Dell router has been crashing on me a lot lately, and I don't know why. I'm running ESXi 5.1 on it. I just bought an IBM M3650 3650 M2. Currently, I run 24 gig of RAM on 2 Xeon processors, and I'm going to be upgrading to 48 gig of RAM on 2 quad-core Xeon 2.8 gigahertz processors. That's what I'm going to. And actually, when I rebuild the server, I'll actually walk through what the updated lab topology is going to look like, things like that. And the main benefit really for it is because the fact of CCIE version 5 is so in depth and such a broad topic spectrum. I've met a lot of guys that are studying for it, and they all say, we all say the same thing. You don't know how big the topology is going to be. Now, version 4 was 5 routers and 4 switches. Well, that was great. You could pull MPLS off, but I don't know how, but you could pull it off. Now, the kicker with that is you probably were just, a router might be a PE and the switch might have been a CE, whatever. You never know. But what they're doing now is in the version 5, because it's all, what are they going, IOL, something like that, I think is what they're doing. And so it's all virtual. That's the one thing about it that's different than all the other exams, is it's all virtual. So what does that mean for you and I? That means that the exam is pretty much, there's no limit to the amount of growth. So you could have 20 routers and 10 switches in your network. You never know. But the main difference between what you're going to see in version 4 versus version 5 is the scale. So they could have you set it up, and the way that the network was actually broken down before was, before the way that it was CCA was delivered to you before was a technologies exam. Same thing with the way it is now. I never actually took the lab for version 4, so I really can't say 100% of the be 100% accurate with this. But what I can say is this: the way that it was delivered, it was hard for some of the things. It was very hardware dependent, so they had to make sure they had the right hardware platforms in place for things to be pulled off correctly. So what we're going to deal with in version 5 is different from version 4 is everything's virtual. So if, like, for instance, you turned on router RIP here, I've heard there's some nightmare scenarios where you turn router RIP on, you type your network statement in, no auto summary, and you do that over here, and RIP route or RIP adjacencies don't form. Now, it's not like OSPF and EIGRP and BGP where you're in LDP, where you actually see the or PIM or any other dynamic routing protocol that you actually see an adjacency form. RIP, you don't see that. So you could have, it could look like it's working. You do a show RIP or show IP protocols and do all your verification commands. Nothing might be there. And Johnny Bass, who happens to be a program manager for CCIE, he's like, well, write mem and reboot. And I'm like, seriously? You just turned the routing protocol on. You just got into the lab and you're already rebooting the router because of some sort of stupid software issue. I'm sorry. If you're going to spend $1,600 to go take a lab to validate your level of as an expert level engineer, they should at least make sure that stuff works. You know what I'm saying? Um, that's why I think they should do some things in GNS3 because I think it's a little more stable, pending the platform it's sitting on, of course. But that's just my 2 cents on the situation. But that's pretty much where I'm at with the way things are rolling with the exam. Um, uh, this wasn't supposed the video wasn't supposed to go this long, but that's okay. One of the other things that I wanted to touch on real quick was I do have the written exam coming up very soon. I'm a little under a week away from it. I won't tell you the exact date because I don't want to get flooded with emails. But pending a pass on my test date, I will go in and I will shoot a quick video of yay I passed or no I didn't, this is my experience. You'll know either way. But I'm pretty confident that I'll pass the exam on my first go. Like I said, I've been studying the written exam since the day that I passed my CCNP, and that was January 4th of this year. So I've been studying for about 8 months now, and I can tell you I'm actually kind of tired of studying for written. In my opinion, there's too much reading involved for the written. I think Cisco should revamp CCNA and CCNP to as building blocks for CCIE. Even if even if you're watching this video now or down the road, if you determine that you don't want to become a CCIE, then that's your call. But I still think they should have multicast and QoS in there and start bringing this up from the get-go. Bring an IS to IS in there. It's usually a service provider technology, but it's I've never actually seen it deployed in production. But then again, I've only been in probably a dozen production networks in my career, so that's one of those things where I guess it is what it is. So, but I do have the written coming up, and as soon as I pass the written, then it'll be gung ho for the lab. I might take a couple days off just to give myself some time to decompress a little bit. But beyond that, that's where I'm at right now. So if you have any questions or concerns, or you'd like to get in touch with me outside of YouTube, I am all about that. Matter of fact, it's one of those things where I prefer it. Oh, I can chat? Oh, I didn't know I could chat in Google. Cool. But anyway, I'm at the end of this video. So my email address, if you're interested, is actually let me type it out to be cleaner. So we'll go to home, we'll go to this guy, and we'll go to text, and my email address is rriker82@yahoo.com. And I hate when it does that. But anyway, that's how you get a hold of me if you are interested in knowing more about whatever it is that I do. I'm more than happy to share. One of the things that I'm looking to do is once I'm done with the Advanced Technologies class, is I'm actually looking to go through and start doing a live with the live lab walkthrough, which is what this topology is supposed to be doing, is do like Google Hangouts and things like that. So for instance, when I have something built, there's absolutely no way that I could possibly think of every scenario out there. I can just come up with stuff off the top of my head, or maybe I think about it on my lunch break, or I hear about a horror story from somebody else's network that broke. I'm going to take whatever it is that I can think of, and we'll lab it up. But one of the things that I would really like to do is start doing some Google Hangouts maybe once a week or whatever on a Saturday evening or what have you. I know not everybody's in the U.S., but the majority of people I think are in the India, that particular area of the world. If you want to get on Google Hangouts and stuff like that, I'm more than happy to do that. Actually, I think it'll be a good learning experience to have like a study group type of deal put together. But that's where I'm at with stuff. I hope you guys can take something away from this and everything works out for you. One of the other things, keep adding stuff in here as I go, is I need to flip over to my pen again. Is one of the things that I'm going to be doing here pretty shortly too is when I get the new server, it's gotta actually click here. When I get the new server, I'm going to be loading up CSR 1000V. And if you go to Cisco's or Google CSR 1000V, you can download it. It basically stands for Cloud Services Router. It runs iOS XE, and if you download the 3.11 version, that's going to be iOS 15.4 equivalency. So if you were to look and do a show version, this is going to be the iOS relationship. This is going to be the XE release. So 15.4 is one of the latest code trains that Cisco's released. And my recommendation, I'm going to download and install probably, you only have to download a single image. And I would recommend downloading the .ova or the Open Virtualization Architecture file. And what that's going to allow you to do is it's going to be a pre-built virtual machine that you can deploy in your ESXi environment. And then if you configure the vSwitch, and I'm actually going to run through, check my YouTube channel out, and you'll be able to see, I actually run you through how to set all this stuff up in ESX using the vSphere client. And what I'm actually going to do is once I get it downloaded and installed, I'll show you guys how to actually go in and configure everything and get it all running. And then we'll be able to use CSR 1000V once we get into some of the technologies that we won't be able to support in GNS3. So like, for instance, we might have to go 2025 routers for our lab walkthrough as a high end with CSR because it is kind of a beefy platform. And then from there, we'll be able to do pretty much everything there is to do with CCIE, and we'll go from there. But I'm going to try my darndest to make sure GNS3 can scale to 30 plus routers and be able to support that. I've gotten 55 in a previous deployment to fire up, but I've never enabled routing on that, so we'll see what happens. But we'll go from there, and then that's the idea behind that. So if anybody has anything they want to talk about or they want to spin up, definitely hit me up. I'm available. It comes right to my phone, so like if you were to send me an email right now and say hi, you probably would hear a chime on the video that you're watching. That's how quickly it comes through. So that's pretty much what I wanted to cover. I hope this has been informative for you. I would like to thank you for viewing, and I hope to see you in the future.